In Activity 7, Talking with the Telegraph, students apply the knowledge they have gained about electric current, magnetism, and electromagnets to create a working telegraph. You will need the following materials from the kit: Activity Sheet 7, Parts A and B, D-cell batteries, electrical clips, delta circuit workspaces, electromagnets from Activity 6, Fahnestock clips, hex nuts and screws, metal strips, large paper clips, paper fasteners, rubber grommet spacers, 15 centimeter plastic insulated wire pieces, roll of plastic insulated wire, and wire cutters. You will also need to provide metric rulers. To prepare this activity, make a copy of Activity Sheet 7, Parts A and B for each student. Each team of 4 students will need an electromagnet from Activity 6, 2 15 centimeter pieces of plastic insulated wire, a plastic base, 3 batteries, 8 electrical clips, 3 Fahnestock clips, a metal strip, a large paper clip, 4 paper fasteners, 4 rubber spacers, 2 hex nuts, and 2 screws. Prepare 2 of the electrical clips for each team by pressing the clips against a table edge to make a right angle bend. Each team will also need 1 piece of plastic insulated wire 25 centimeters long and 2 pieces of plastic insulated wire 60 centimeters long. Strip the ends using the wire cutters. To begin Session 1, ask students, what are some things you could make with an electromagnet? Students may mention devices that pick up objects or other applications such as stereo speakers, buzzers, or motors. Inform the students that they will use what they learned about electromagnets to build something that will enable them to send messages to other students, a telegraph. Divide the class into teams of 4 and distribute Activity Sheet 7, Parts A and B. Demonstrate for the class how to assemble the switch. The switch is constructed from 2 rubber spacers, 1 Fahnestock clip, and a large paper clip. It is held to the plastic base by 2 paper fasteners. In a properly constructed switch, the loop of the paper clip will be attached to the Fahnestock clip, and the clip will hover above the second paper fastener. Placing rubber spacers between the paper fasteners and the plastic base adds stability. Next, assemble the telegraph by inserting the metal strip between the 2 slots in the plastic base. Insert a screw into each of the 2 bent electrical clips, push the screws through the holes in the base, and attach the nuts to make a secure attachment. Insert the electromagnet into position. Then, show students how to connect 2 batteries in a series and complete all connections. Next, distribute the materials to teams of 4. Have the class construct their switches and telegraphs as described in Steps 1 through 3 on Activity Sheet 7, Part A. Offer help as necessary and encourage experimentation. Explain that a telegraph is a device for transmitting coded messages over wires. A telegraph consists of a transmitter, or switch, and a receiver, or electromagnet. After students have tested their telegraphs, ask, how do you think the telegraph works? Help students understand that when the switch is closed, the electric current flows from the batteries through the wire to the switch, then through the wire of the electromagnet and back to the batteries. This current causes the nail to become an electromagnet and to attract the metal strip to the bent electrical clip, which it hits with a resounding click. To conclude Session 1, allow students some time to experiment with their telegraphs and leave them intact for Session 2. To begin Session 2, inform students they are going to wire the electromagnet and batteries on their base to the switch on another team's base, and the switch on their base to the electromagnet and batteries on the other team's base. At the same time, they will add a 3rd battery to each base and extend the distance between the switch on each base and its corresponding telegraph. Redistribute materials to each team. Help students add a 3rd battery to each base and wire it in series using another 15 centimeter piece of plastic insulated wire and 2 more electrical clips. Next, attach 2 Fahnestock clips to the base by using paper fasteners and attaching rubber spacers to the back. Disconnect the ends of the electromagnetic wire and attach each end to one of the newly attached Fahnestock clips. Also attach a 60 centimeter piece of plastic insulated wire to each Fahnestock clip. Place the base near another team's base and use the 60-centimeter wires to connect the bases at the switch and batteries. Next, define communicate as to share information, ideas, feelings, or knowledge. Then, have students imagine that telephones and radios have not been invented yet and ask, can you think of a way to communicate with family and friends who live across town? Students should realize that if they had enough wire, they could separate their switch and telegraph and send messages over a much greater distance. Tell the students that the telegraph was a unique communication tool, but that in order for it to work, the person sending and the person receiving messages needed a common language. They had to have a code. Inform the students that in this session, they will use their telegraphs to send messages in Morse code. Have them retrieve the telegraphs that they built during Session 1. Bring the students' attention to the Morse code at the end of Part B of Activity Sheet 7 and ask, what is Morse code, and how could you use this code and your telegraph to send a message to your teammate or to another team? Explain to the students that Morse code is a means of communication based on the representation of letters and numbers by combinations of dots and dashes. These dots and dashes can be transmitted visually using blinking lights or by audible means using clicking sounds. Finally, have the students experiment with transmitting messages in Morse code on their telegraphs. To conclude Session 2, have students dismantle their telegraphs except for the bent electrical clips. Leave the clips attached to the circuit bases. Return the other materials to the kit. Many of these items will be used again in the activities that follow. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.